Our next example requires some fancy algebra and complex fractions. So the first thing I want you to do is change the delta x to h everywhere and put your complex fraction together. Make it one nice, neat fraction using common denominators. When you have it cleaned up, come on back. Once you're done with all of your fancy algebra, you should be asked to find the limit as h approaches 0 from the left of the more simplified function negative 1 over x times the quantity x plus h. Before we actually evaluate that limit, let's take a quick look at the algebra that we used in order to clean this up. The first thing I did was I tried to subtract in my numerator. In order to do so, I needed to find an LCD. So in order to subtract 1 over x plus h minus 1 over x, I needed to find my LCD, which was x times the quantity x plus h. I then rewrote each fraction with the new LCD, distributed this negative into this whole piece, and then I was able to cancel and simplify, get rid of those x's in the numerator. So then I was left with the problem, find the limit as h approaches 0 from the left of negative h over x times the quantity x plus h, all divided by that h from the very original problem. That h, therefore, ended up in my denominator, so I was asked to find the limit as h approaches 0 from the left of negative h over x times h times the quantity x plus h. The two h's cancel, so now I'm right to where I left off earlier, with the limit as h approaches 0 from the left of our function negative 1 over x times the quantity x plus h. Again, even though I'm asked to find the left-hand limit, as long as the general limit exists, that means that the left and right-hand limits are the same. So let's plug in 0 for h and see what happens. If I plug in 0 for my h, I then have negative 1 over x times the quantity x plus 0, which is going to give me negative 1 over x squared.